Hello and welcome to TED Talks. Our security edition today is focused on user behavior analytics. TED Talks is a series of short webinars focused on features and best practices. We value you, our customer, and want you to continue in your Splunk journey. Our experts helped create these tips and tricks, and we want you to leverage them in your daily role. I'm Jairo Camacho, a product marketing specialist supporting user behavior analytics. I'm excited to share more about UBA's capabilities and introduce my colleague, Kaulik Ghosh.
Hi everyone, I'm Kaulik Ghosh. I'm the product manager focused on UBA at Splunk.
Thanks, Kaulik. Today, we are going to discuss the potential risks imprecise security coverage can pose to your organization. We'll also discuss how Splunk UBA can identify gaps in your security coverage, and Kaulik is going to walk us through a great demo of UBA. Then we will cover additional resources available to help you take advantage of UBA's capabilities. Our team will be available for Q&A throughout the presentation over the Q&A feature. And if you are watching a recorded version of this webinar, please continue the conversation through the Splunk community website for any follow-up questions. Also, stay tuned for a few poll questions at the end to share your feedback. Let's start off with, what are some of the challenges security teams currently faced? First of all, insufficient security coverage provides threat actors with an ideal situation, plenty of places to hide. On average, it takes 279 days to identify and contain a breach, giving them ample time to find the right vulnerability to exploit. Second of all, the inability to properly gauge the level of coverage within your environment can provide your organization with a false sense of security. And third of all, while many consider insider threats incidents to be malicious in nature, most are simply caused by negligence. Regardless of intention, the cost to an organization is steep. For example, if it takes an organization 30 days to neutralize an incident, it usually costs somewhere between $7 million. But if it takes longer than 90 days, that number leaps to about $13 million. Together, we can identify and address potentially problematic blind spots in your environment before they can really cause havoc. Now, how can UBA increase transparency across your security posture? It's built on the world's first data-to-everything platform, which can ingest any machine data regardless of source or format. UBA's seamless integration with Splunk Enterprise Security enhances threat visibility, leverages machine learning to detect unknown threats and anomalous behavior. Security use cases like data exfiltration outline which data sources must be ingested to protect your organization. They provide the parameters needed to gauge whether your organization has sufficient coverage. Splunk Common Information Model is a shared semantics model focused on extracting value from data. It's capable of validating ingested data to determine if you are getting what you expect from your available data sources. Now, let's hear from Kaulik and see that incredible demo.
Thanks, Jairo. Splunk User Behavior Analytics uses unsupervised machine learning to identify advanced and insider threats within the customer's network by monitoring the anomalous behavior of users, devices, and applications. One of the most powerful features of Splunk UBA is the custom content framework, which enables users to develop their own machine learning models using Splunk UBA. As part of this functionality, customers can onboard any data source, even coming from custom applications within your networks, take that data source and aggregate that into large cubes, and then develop machine learning models on that aggregated data to identify unique detections within your network. In this tech talk, we'll explore a slightly different application of the custom content framework. Based on our discussions with customers, we have realized that they are using the custom content framework to identifying logging gaps within their network. These logging gaps can lead to blind spots and have big gaps in your security coverage. So let's see how we can fix these issues using the custom content framework and Splunk User Behavior Analytics. As a premise to this demo, you can perform a suspicious activity in your network. In our case, we ran a PowerShell command for doing credential dumping, but based on the tools that are available to you, you can do something similar or something even simple like exfiltrating a large amount of data from your network to an external location. Once you have done that suspicious activity, you may want to come to UBA and check if that anomaly is visible in UBA. You can go to the anomalies table page and you can filter the anomalies by multiple different parameters like event date, by source format, and by anomaly type. No surprises here, but we did not find that anomaly. So the first thing that we would want to do is that go to Splunk Enterprise Security and check if the events were being indexed in ES. We know that when the activity was run, what are some of the logging sources. In this case, it will be Windows security events, and we can fine-tune the timing filter to identify if the events were flowing in. In this case, we see that there was one such event coming into Enterprise Security related to this incident. So there seems to be an issue, but where do we even start troubleshooting it? This is where the custom content framework comes in, and we can go to the UBA workflow and review the list of cubes already shipped within the product. This lets us deep dive into the fields and events that are available in each of those cubes and what are the values that these fields are expecting. By reviewing all of these cubes, we can figure out which are the cubes that we want to investigate further in our troubleshooting exercise. In this case, we know that this would be the PowerShell event cube. So what do we do next? Let's open up the terminal and SSH into the second node of UBA. This is where we can access Impala to run some SQL queries. We start the Impala shell, and then we query the PowerShell table to see what are the events coming in. We can filter down to the date because we know where exactly the event happened, and then we can check for some particular fields like user ID, username, and see what are the values getting populated into the PowerShell table from the incoming data sources. Looking at the results from that query, we see that there are some events populating the cube. But upon investigating it a bit further, we see that the usernames of all the events are the same. Everything seems to be coming from a service account starting with SVC. What does that mean? Investigating this a bit further, we edit the query and add the user ID which we know has performed that suspicious application. And we rerun that query. No surprises here, but that query returned 0 results. Now things are getting really interesting, and now we know that this might have to do something with the username. Putting our investigative hats more, we check for all the distinct users who are populating that PowerShell table. And running that query, we see that the entire table has results for just one particular user, which means that there is no data coming in from any other users. This can be a bit problematic. We might lose any security incidents happening with any other users running PowerShell events, but before raising the alarms, let's verify this in some other cubes as well. So we can go back to the UBA UI, look for the other cubes which have PowerShell related events, and investigate if the other ones are getting populated as well. So we'll quickly verify this in the Windows security events table, and we'll run a similar query which looks for event ID, which looks for process name, which looks for target account ID from the Windows events cube, and we look specifically for the event ID 4688, which means a new process has been started. And we also further tune the query down to look for processes which start with P. That means that would cover up the PowerShell related anomalies. We remove the time window to have an all-time search within the database, and we see over here that there are very few events related to PowerShell activity even in the Windows events cubes. We see that same account name, which was the service account that we saw earlier in the PowerShell event cube, and we see 2 additional accounts, but that means that we are really lacking security coverage for any other devices which might be running PowerShell related commands. So this leads us to 2 conclusions. The first one is that the PowerShell events themselves are flowing. That means we are getting those events into UBA and it's populating the PowerShell event cube as well as the Windows events cube. But there is something really wrong with the user info, because of which we are dropping a lot of events and are unable to capture any incidents happening with those users. But what's the exact root cause? We need to identify that to improve our security coverage. So let's go ahead and find that out and fix that. Now we go into the UBA UI and we narrow down the search which pulls the Windows security events from Splunk Enterprise Security, and we narrow down that search to just look for event codes starting with 4688. We edit that search and we clone the data source and put it in test mode. What test mode does is that it samples a few set of events coming in from Splunk Enterprise Security so that we can preview what are the types of events we are getting in UBA without affecting any of the downstream analytics or the detections. In this case, you'll see that we found some 207 events, and we can review these events to see what exactly is going on in them. The next step is to check for the parsed events. The UBA test mode enables us to investigate the incoming events in a granular way. Here we can look at the raw event itself, and we found one which was related to the PowerShell, and we can investigate the fields and values coming in from the incoming events. This particular event shows us the root cause, and that root cause is that the username is the same as the computer name. So what UBA would do is that it would look for that username within HR data, and if it's not able to find that username, it will drop all of those events. And as a result, there is a huge blind spot, as this issue in the incoming events is leading to gaps in your security detection. This issue is very small, it's hard to miss, and unless you have already developed some of your other use cases or content to leverage this information in Splunk Enterprise Security, it can be something which is easily overlooked and can lead to problems later on. So we just covered an end-to-end walkthrough of how you can use UBA, the custom content framework, and also go into the cubes to investigate what is the level of logging and if the right fields and values are coming into UBA. There are some other hygiene items and best practices that you can also leverage in improving your security posture. You can check for the TA versions of Windows. The Windows security events and the Windows events contain a lot of info. The logs are of huge volume, and then there are multiple TA versions. So you can plan your roadmap to have consistent TA versions to do the parsing correctly for the incoming data sources. Similarly, for other data sources and applications, different appliance versions have different logging and they have different TAs as well. So you can use this to identify what are the fields and values that are most important to you and plan your project to fix that as to what's highest priority in your network. Another great application is the SIM Validator app, which you can install on your search head to check how SIM compliant the different data sources, especially for the ones which are relevant for either enterprise security or Splunk user behavior analytics. And finally, this gives you the data to plan your roadmap and your strategy into fixing what's most important to you with the resources that you have available. There are some further documentation available and additional resources. So for the SIM Validator app, you can have a look at this link, as well as this is a great Splunk talk given at .conf 19, which provides some best practices into managing your UBA environment.
Thanks, Kolit. We have an incredible community of Splunk users on our community website. There you will find a Q&A section to learn more about how Splunk UBA can help identify security gaps. Also, feel free to participate in the new discussion section with security TED Talks as well as Splunk Ideas, where you can now submit ideas for product enhancements. To wrap things up, we have 3 survey questions that I will walk you through to make sure this is a useful conversation. Did this TED Talk resonate with the challenges your SOC is experiencing? Are you interested in learning more about the benefits of integrating user and entity behavior analytics functionality in your security environment? Would you like more guidance on running more red team tests on your network to verify your security network? We appreciate you taking time out of your busy schedules to join us today. Please tune back in for future TED Talks. We are excited to share the series with you. Thank you again.